What if you fell into a black hole right now, feet first, with no way to stop yourself? You might expect a violent, crushing death at the edge, but physicists say something far stranger happens instead. You would cross the point of no return without feeling anything at all. No alarm, no wall, no warning. The real horror begins after that. Invisible line where time and space literally swap roles, making escape as impossible as traveling backward in time. That boundary has a name, the event horizon, and it leaves absolutely no physical trace on your body. There's no surface there, no wall of fire you'd feel the moment you pass through. The event horizon is just a location in space, defined entirely by what it means for your future. Once you're inside, every path forward leads deeper in. Not because something is pulling you, but because deeper is the only direction time allows. That's the part most people never expect, and it changes everything about how you understand what a black hole actually is. Your friend watching from a safe distance sees something deeply strange as you fall toward the black hole. From their vantage point, you slow down, and never quite arrive. The light leaving your body takes longer and longer to climb back out against gravity's pull. To them, you're frozen at the edge, dimming and redshifting into silence over what feels like forever. But your own watch tells a completely different story, one that doesn't pause for anyone. You feel no dramatic slowdown, no warning signal, no moment where the universe taps you on the shoulder. You cross the event horizon in finite time, clean and unremarkable without a single alarm going off. The two of you are living inside the same event but experiencing entirely different versions of it. One clock says you're still falling, the other says you're already through. Neither clock is wrong. They're just answering the question from opposite sides of a boundary that bends time itself. Past the event horizon, the geometry of reality does something that defies every instinct you have about space. The direction pointing toward the singularity stops behaving like a direction in space. It starts behaving like a direction in time. You can no more turn around and fly back out than you can turn around and fly back into yesterday. That's not a metaphor, it's the actual mathematical structure of the space-time inside a black hole. In ordinary space, you can choose to move towards something or away from it. Inside the horizon, moving toward the singularity is like moving forward through a Tuesday afternoon. It just happens, whether you want it to or not. Every path you could take, every rocket burn, every desperate maneuver, they all lead forward through time. And forward through time means closer to the singularity. Escape isn't blocked by gravity the way a wall blocks a door. Escape is forbidden by the same logic that forbids you from unliving this moment. Gravity doesn't pull your whole body equally, and that difference is what kills you. The side of you closest to the singularity gets pulled harder than the side facing away. That gap in force stretches you the way you'd stretch a rubber band between two fingers. Physicists call this spaghettification, which sounds almost funny until you think about what it actually means. Your body gets drawn into a long, thin stream of atoms falling in single file. For a stellar mass black hole, this tidal tearing starts well outside the event horizon, while you can still, technically, see the universe around you. But for a supermassive black hole, one with billions of solar masses, the tidal forces at the horizon are gentle enough that you'd cross without feeling a thing. The killing blow comes much later, closer to the center where the gradient grows steep enough to overwhelm any material in existence. No substance, no structure, no force in physics holds together against what waits at the end of that fall. Most people picture the singularity as a point sitting at the center of a black hole, waiting. That image is vivid, and it is almost certainly wrong in every meaningful sense. The word singularity doesn't describe a location the way a city or a coordinate describes one. It marks the exact moment where the equations of general relativity simply stop producing answers. Think of it like dividing by zero on a calculator. The machine doesn't give you infinity, it just gives you an error. The math breaks down, and physicists take that breakdown seriously as a signal about the theory itself. General relativity, The framework that governs black holes reaches its own edge at the singularity. What lies beyond that edge isn't exotic or mysterious, it's genuinely unknown and possibly unknowable with current physics. Some researchers believe a future theory of quantum gravity will replace the singularity with something finite and describable. Until that theory exists, the singularity is less a place you fall into and more a question the universe refuses to answer. The equations that describe a black hole don't actually stop at the event horizon or even at the singularity. When physicists solved Einstein's field equations completely, they found something genuinely strange hiding inside the math. The full solution describes not one region of space, but four, connected in ways that feel more like science fiction than science. One region looks like the black hole you'd fall into from our universe. Another region is its mirror image, a second universe entirely separate from our own. A third region is what mathematicians call a white hole, where matter can only flow out, never in. The fourth region connects all three through a structure called an Einstein-Rosen bridge, what most people know as a wormhole. On paper, you could theoretically pass through that bridge and emerge somewhere else entirely. The problem is that this wormhole pinches off faster than any signal or any traveler could ever cross it. The math allows the tunnel, but physics slams the door shut before you reach the other side. The moment you cross the event horizon, nothing around you announces the fact. You feel no wall, no jolt, no sudden change in the air you're breathing. But look up, and the universe has already started doing something deeply strange to your eyes. Every star in the sky is being pulled forward, compressed into a shrinking circle of light directly ahead of you. Behind you, where you came from, there is only a spreading, absolute darkness eating the stars one by one. That circle of sky above you is getting smaller with every second, like a window closing on a room you can never re-enter. The light pouring through it is blue shift, pushed to higher and higher frequencies as it chases you down. You're watching the entire visible universe funnel into a single bright point, and it's beautiful in the most terrifying way imaginable. The physics isn't punishing you with fire or pressure, it's punishing you with geometry. Every detail about you, your memories, your mass, your exact arrangement of atoms is encoded in the universe. Physics says that information can never truly be destroyed, only transformed into something else. But when you cross the event horizon, that information appears to vanish from the universe forever. Stephen Hawking showed that black holes slowly radiate energy and eventually evaporate, leaving nothing behind. No record of you, no trace of the atoms that made you, nothing. That would mean the universe can lose information, which breaks one of the deepest laws we have. Hawking spent decades wrestling with this, and the physics community still hasn't agreed on an answer. Some say the information escapes in the radiation, scrambled beyond recognition, but technically still there. Others say it's preserved on the horizon's surface like a cosmic hologram. The question your imagined fall raises isn't just personal. It's the crack in the foundation of everything we think we know.